All right, so I'll let you pause the video and read the context, but essentially we've got a bunch of information about coached and uncoached students that took SATs. This first question asks, uh, we're looking at part B in this video, but the first question asks you could use the information on the coached line to carry out either a two-sample t-test comparing try one with try two for coached students, or a paired t-test using GAIN, which is a correct test and why. So first and foremost, this would be a paired t-test using GAIN would be the appropriate test here, because essentially you have the same subjects. So if we have the same subjects and we're applying a treatment to them, subjects, we're applying a treatment, two different treatments to the same subject, we should look at the differences between those. And so a paired t-test looking at mean differences and testing to see if those mean differences are significant or not um, is the way to go here. So the proper test is a paired t-test. We want to carry out that proper test here. So we're going to go through state, plan, do, and conclude for a paired t-test on this particular one. And that's a little bit weird because you got all this information. And in this particular part, they're only asking you to look at the coached students. And in particular, they just want you to carry out a test to see if we took this sample and found these differences, the GAIN in this particular case, is that significant enough to say there is a significant difference between try one and try two on SAT score. So let's go ahead and go through the process. So under our state, we want to talk about the test. So let's go ahead and do that. This is what that looks like. So we want a hypothesis test for the average differences or the mean differences in SAT score between try one and try two, and then make sure you state your alpha level. Next will come the null hypothesis and the alternative hypothesis. So those look like this. Null hypothesis says essentially that the mean differences are zero. There is no significant difference between try one and try two. And alternative hypothesis says that the mean differences are bigger than zero. So there is a difference between try one and try two, and more specifically, try two is higher than try one. So we get a greater average score on try two than we do on try one. And lastly, we want to define what mu sub d is in this particular case. So that looks like this. So we define what mu sub d is. Mu sub d is simply the difference between try one and try two on the SAT. So on to our plan portion where we want to check the conditions. So that looks like this. So down here in our plan portion, we want to know that our data is random. So let's go ahead and look at this. We've got random sample up here of students who took the SAT twice. So we're good there. Our sample is built randomly. So that's good. Our sample of 427, because we're only looking at the coached students in this particular case, 427 is probably less than 10%. I'm assuming there were more than 4,270 students that took the SAT. Or I guess it would have to be 10% of all the students who took the SAT twice. So I guess we would have to assume that that's true. At any rate, assuming that this is true, we'll go ahead and move on. And then the number of differences that we're measuring or that we're looking at here has to be greater than or equal to 30, and we have 427. That's certainly greater than or equal to 30. So we can assume that the differences will be normally distributed, the sampling distribution of the differences. All right, let's go ahead and move on to our do. So this is where we specify the test. So here we want to do a one sample t-test for the mean differences. So anytime we run a t-test, we got to make sure that we specify the degrees of freedom and also our t-statistic. In this particular case, our degrees of freedom are 427 minus 1. So we've got 426 degrees of freedom. And then the t-statistic, you can use your calculator to calculate this. or we can go ahead and do it by hand. So let's go ahead and do it by hand. Our T statistic is going to look at our sample difference, 29, and subtract the population mean difference, which we're running this hypothesis test here, and we're assuming that the differences are 0. There is no difference. So 29 minus 0, we're going to divide that by the standard deviation of the sample. So that is 59 over root n. So the square root of, and our n here is 427. So that's how we calculate our T statistic. Again, you can use your calculator in order to calculate that, but that's how you would do it by hand. It's pretty quick. Simplify and you would get something that looks like this. All right, so a little bit of math with the calc. You come up with this T statistic of 10.1569, very high T statistic. So we should hopefully be able to anticipate what this outcome is going to be. But let's go ahead and do that. So we've got to run our one sample t-test. So let's jump over to the calculator, enter the relevant information, come up with a p-value. All right, so over on our Inspire software, I'm going to go down to statistics, down to stat tests, and we want a one sample t-test, or just a t-test. And this is for, remember, this is for mean differences. So we're going to enter stats. Our hypothesis, our null hypothesis, is that the mean is 0. Our X bar is we had the average differences of 29, standard deviation 59, and we had 427 people that were coached take the test twice. So alternative hypothesis, remember, was that our average was bigger than 0. It's a one-tailed test. So let's go ahead and run this. When you run it, you can see a couple of things that we already calculated. Here's the T statistic that we calculated. Here's the degrees of freedom that we used. And then the p-value is essentially what we're after here when we run this test. So look at the p-value, extremely small, extremely small. So we're not even going to write that p-value. We're just going to say it's extremely small. And let's go ahead and go back and make our conclusion. All right, so we wrote our p-value response, or our p-value output up there under do. I've completed that step, so let's go ahead and make our conclusion based off of what our test tells us. So remember, we're looking at measuring the differences, and we're measuring the differences between try 1 and try 2 on the SAT. Our null hypothesis was that there was no difference between try 1 and try 2. So what we want to do is we want to take our p-value, compare it to the alpha, and make a decision based on the null hypothesis, or make a decision on the null hypothesis based on that. So let's go ahead and do that. Here's what that looks like. So with a p-value that is super tiny, we reject H naught at the alpha equal 0.05 level. So what's coming up next is essentially, what does it mean to reject H naught within the context of the problem? And that looks like this. So we find statistically significant evidence of a difference between the SAT scores on try 1 and try 2 of coached students. In other words, there is a difference between try 1 scores and try 2 scores of coached students.